Okay, projectile motion. We're going to try and blow through some of this for a few minutes. So, when you are in free fall, the only force acting on you is gravity. And that means there's an unbalanced force, okay? So we're going to have Newton's second law. That is our net force equals mass times acceleration. And the object is going to have an acceleration. If we're unbalanced, that means we've got an F net value. That means we've got an acceleration value. So our object is going to be accelerating, okay? And our acceleration due to gravity is the same as we learned, okay? No matter what kind of object you are, you're going to have the same acceleration. So here we've got two different mass rocks that we're dropping, but they're going to have the same acceleration. The small rock is going to be our minus 9.8 meters per second. Same with the large rock, okay? Acceleration due to gravity does not depend on mass. It's an independent thing from mass. If we drop these two rocks from the same height at the same time, assuming there's no air resistance, they're both going to hit the ground at the same time. Again, because mass doesn't matter here, okay? What matters is that they're at the same height. So they're going to spend the same amount of time in the air. Okay, we drop a penny, hits the water 3.6 seconds later. How far did it fall? Here's where we use our height, or dy as we call it, equals. It's really initial velocity times time plus 1/2 gt squared. This term can go away because the penny's starting at rest because we're holding it and then we drop it. So if we want to get this height, how far did it fall? We can use this expression. So we've got 1/2 times our 9.8, and then 3.6 is my time. I have to square that, okay? So I'm going to have, when I put that in my calculator, I'm going to use 0.5 for 1/2 times 9.8 times 3.6 squared gives me 63.5. And there's a minus sign here. This is really like a minus displacement. If we think about dropping it, it's moving downward in a negative direction, but that's how far it's going to fall. Okay. Okay, let's see. You drop and you shoot a bullet from the same height at the same time. They're going to hit the ground at the same time again. Okay. Yeah. Because the horizontal and the vertical parts of the motion are independent. This is where we started talking about projectiles, how we've got horizontal velocity that's constant, and then we've got vertical that depends, that's governed by basically the acceleration due to gravity. An object is launched up and to the right as it moves through the air. The horizontal velocity is constant because there is not a horizontal force on it. So we looked at different types of projectiles and we learned that the horizontal piece of the velocity is a constant piece because there's no force acting horizontally. Same object for vertical velocity, it is going to change, okay? It's not constant. And that's because of acceleration due to gravity. At the top of the arc, so this is where we drew a lot of these diagrams that look like this, okay, and we had our different velocity vectors. We had our vertical. At the top of the arc, the vertical velocity is going to hit a 0 value. And remember, it doesn't stop there, okay? It just crosses over 0, but it's also changing direction at that point, okay? Okay, we're going to kick a ball off a bridge that is 21 meters tall with an initial horizontal velocity of 4.5 meters per second. What's our time in the air? How far away does it land? Okay, so these are all questions that went back to the horizontally launched projectile. Time in the air we found for this, we used 2 times our height divided by g. So the bridge is 21 meters tall. So I'm going to do 2 times 21 and divide that by 9.8. That gives me 4.2857. I'm going to take the square root of that. 4.2857 gives me 2.1 seconds in the air. Okay. How far away from the bridge does it land? This was our range, is my horizontal velocity times my time. And these are all equations we went through for the horizontally launched projectile. Hang on a second. Okay, I'll pick